My name is Jason Slabotsky. I am the Teacher Support Specialist at the UTeach Institute at the University of Texas. Um, as you could tell by my accent, I am not a Texan. I spent the last 15 years teaching in New York City before moving to Texas to join UTeach. And good for you, I've taught the I taught the AP Computer Science Principles course since its inception. And in addition to teaching the course, I am also an AP reader, and I grade the create performance task for College Board. So, given that background, what we're going to do here this evening on the webinar is I'm going to basically teach you a bunch of, not tricks, but tips to better prepare your students so that they don't make the common mistakes and hit the same pitfalls that other students do. I'm very excited. We're also going to talk about the do's and don'ts for you as a teacher, because you don't want to get in trouble by College Board for doing something you shouldn't do. So so just a couple things like that. We're going to go over, and whole webinar should be about 20 minutes or so. I'll save questions to the end. If you have any questions, please enter them into our chat box, and we'll answer them at the end. And also, if you're joining us late, just make sure you mute your microphone so I don't get any background noise. All right, so like I just said, I'm going to start off by doing a brief overview of the create task. Then we're going to do a deep dive into the scoring guidelines. Valerie, yes, you will have access to this slide deck. So we're going to then go into the scoring guidelines, which is very important. Sometimes they can be confusing for the teacher and the students. Like I said, I'm going to go over some do's and don'ts and some logistics as well for the teacher so that you administer this the way you're supposed to, and that your students have the best chance of getting a perfect score. So let's start off. The create performance task. First, let's do an overview of it. College Board officially says students will be developing a program of their choice. The student's development process should include iteratively designing, implementing, and testing their program. Now, the reason why they word it like that is because they want the students to be creative. Not like they're telling them they have to do a certain thing like a game or a calculator. No, they want them to be creative with this. Henceforth, the create performance task name. The students are going to have to submit 3 different things as part of this performance task to the digital portfolio provided by AP. They're going to have to provide a video of their program running, and we will discuss that coming up next in detail. They're going to have to also submit their individual written response about their program, and more importantly, about the development process. And they also will have to upload their entire program code. And as well as upload the entire program code, they're going to have to mark certain sections of it and submit that into their written response. Now, first question I usually get from teachers are, can students work together? Now, when you did the explore task, it was real easy. Students can't work together. Now, you as the teacher, you can make the decision whether they can work together or not, but College Board encourages the students to collaborate. Usually it's during the planning phase or the designing phase, but especially in the debugging phase. College Board does not want the students to collaborate at all on the written feedback, on the written response, or the video submission. So the only part that the students can collaborate on really is the planning and the design. If you're going to let them work together and they do the coding together as well, each student has to make sure that they leave notes in the code who did what, that they were responsible for this. And also when they do the written submission part, they wouldn't be allowed to submit the same algorithm and the same abstraction. They would have to each submit different ones. So like I said, College Board allows them to collaborate. Could become a little confusing on what parts they are allowed to collaborate on and what parts they're not. So I just wanted you to make you aware of what College Board says. Me as a teacher, I would make the students work individually, but then they would collaborate on the debugging part of their projects. Now, what this is a condensed version of the scoring guidelines. And we're going to review this because everything College Board does is a little confusing. So I want to make it as clear as possible for you, the teacher. Now, the students are going to have to fill out a written response. And in that written response, there's going to be 4 sections, 2A, 2B, 2C, and 2D. So you would say to yourself, the students have to fill in 4 boxes. They get like 4 grades. No. Even though the students are going to fill in these 4 boxes, 2A, 2B, 2C, and 2D, College Board actually grades them on 8 different what we call rows. So really, for the video, which is 2A, they're just being graded 1 point on row 1. And each one of these rows is worth 1 point. So that's 8 points total. So the video is just 1 point out of 8. Section 2B that they're going to fill out, and this has to deal with developing a program with a purpose. So this is row 2 and 3. It's worth 2 points. So just wanted to show you that even though the students have to fill out 4 things, it's not equally weighted. 2A is only worth 1 point. 2B is worth 2 points because there's 2 rows. 2C is worth 3 points because row 4, 5, and 6 of the scoring guideline each has to deal with 2C and the algorithm. And then 2D, which has to deal with the student's abstraction, is worth 2 points, and that's graded on row 7 and 8. And this is the scoring guides over here for each row. And we are going to go deeply in to each one of these tasks and rows in the coming slides. But I just wanted to make you aware of how it is scored. So I'm a reader for College Board, and I have to basically go through and see for each of these rows if what the student submitted in these 4 boxes gets them a point for each of these rows. And that's the goal. Your goal is to get the students all 8 points. So you might be asking yourself, which are the hard rows, all right? As a teacher, I used to think about that, right? What is the hard row? So what you're seeing right here, this comes from the AP Chief Reader Report. You can Google that, AP CSP Chief Reader Report, after my webinar, not during it. You can Google that and pull up this past year's report that the chief reader makes up, and on it is how each student scored on average on the create task. And the reason I'm showing you this is a couple reasons. Like number 1, I just said row 1 just has to deal with the video. And it's worth 1 point, and on average, they get a 0.96. So basically 96% of the kids are getting that 1 point. All right, so it's a very easy point for them to obtain. Now, what really is troubling is rows 2 and 3. Rows 2 and 3, that's talking about the development process. I didn't say the way they develop their code. I just said development process. So rows 2 and 3, they should be talking about how they came up with the idea for their program. Then, we're going to review this, the iterative nature of the development process. And so this has nothing to do with coding rows 2 and 3, and yet students are not doing well on rows 2 and 3. Rows 4, 5, and 6 have to deal with the algorithm, and then rows 7 and 8 have to deal with the abstraction. So just wanted to show you how the averages for each section so that you can see, oh, you know what, my students, I'm going to really have to focus on row 6 because for some reason, they're not getting that point. So now let's talk about the rows and the actual tasks. Okay, so row 1, that was tough to say. Row 1, this is going to be response 2A, and it's going to go into that box on the written response. And this is all about the video. Now, you can read this on your own. So what I'm going to do for each of these sections is I'm just going to give you like the hint, the tip, and what you need to know in order for your students to have success. So the video, and we're going to watch a video right after this. The video must show at least one feature of the program running, even if it's only for a few seconds. I like to have my students show more than one feature because I wanted them to show that it's a real program. In other words, that like if your students design some sort of game and in the game they get killed, does the game restart and does a life get taken away from the lives at the top of the screen. So, just wanted to let you know that they need to show the program running. And we'll get into the details in one moment. They can actually narrate their response. They're allowed to do that this year. Starting next year, it's a no-no. But for this year, they're still allowed to do that. Must state the function or intended purpose of the program. And like I said before, all the students get this point. Even the students whose programs don't run correctly, if they record it and they have at least one feature of the program running and everything else doesn't work, they'll get the point. So let's watch an example of a video that a student submitted, and it did get the 1 point. Now, all of these examples I'm going to show you come straight from College Board's website. The link is down there. This is sample A from the College Board examples. Oops. So you notice the student starts the program. Now, he created a game where you go around the world hitting these dots and collecting points. I did read the written response for the student. Notice it's a screen recording. It's not allowed to be longer than 1 minute. Technically, readers are supposed to stop watching at 59 seconds. Now, this student is smart. He shows that you can restart the game and that it does work. And now he demonstrates another aspect of it. And this right here will get you the 1 point for the video. Now, video submission, there is a lot of technical skills involved in this, and you're going to want to make sure your students are prepared to do this. Don't take it for granted that if they can use Snapchat and they can go on the TikTok app, that they have any idea how to really convert files or do screen capture. So they need to demonstrate the running of at least one significant feature of the program. I would tell my students to show 2 or 3. It can't be longer than 1 minute. It also can't be longer than 30 megabytes. They need to submit it in either MP4, WMV, AVI, or .mov. If that's it, they can't use any other formats. The digital portfolio will not accept them, and we're not going to be able to read them as readers. What tools should you use to record the screen? Screencastify is one of them. Screencast-O-Matic is free. It's available online. Students like to use that. Also, QuickTime, if it's already installed on the computer, I don't know if you're aware of this, but on QuickTime, if you go to File, you can do a new screen recording and capture the screen running. And also, your students are allowed to edit their videos. So if they want to record 3 minutes and then just make a highlight reel of 59 seconds of the best parts, showing all different significant features, that would be great. And like we already said, they're allowed to narrate it, and they're going to have to upload it by themselves to the digital portfolio. You cannot help them as a teacher, and we will get back to that in the do's and the don'ts. So they made a video. They submit it. It's only worth 1 point. Now, next part is 2B. 2B is going to talk about the way they develop their program with a purpose. So this is worth 2 points. This is important. Your students need to keep a journal during the development process. In order to be able to do part 2B and get those points for row 2 and row 3, they need to be able to go back and look at their notes. And they need to keep a journal of the development process. And this is the development process you need to teach your students. They need to first investigate and figure out a problem, okay? And that's up to you. Usually they like it to have some sort of impact on society for good, or for some social cause that's good. So let's say, for example, they do an investigation and find out a lot of kids in their school don't have glasses and they need glasses. So then they start a plan and they start to learn more about how much it costs to get glasses and buy glasses. And the kids in the school, they can't afford it. The school, gets a lot of free and reduced lunch. So the kids can't go out and buy, a new pair of glasses for $100. So then they start to design, and they come to think of, maybe we can design some sort of program where kids can donate their old glasses, and then kids who need it can pick them out. And then what are they going to do? They're going to design a plan. They're going to start to make up their program. They're going to start to write their code. And then they're gonna test it out. And this section right here, create and evaluate. This is the iterative development process, okay? College Board and developments in general don't believe that you come up with an idea, you make it, and it works great, and nothing went wrong along the way. No, they want to hear about the difficulties the students had and how they overcame these difficulties and what they did differently in the project. So this is why it's important to maybe have the students work together on debugging, because a student can come up with something and then have another student test it out. And during the debugging phase, shoot it back and let's come up with another way of doing it and test it again. And then let's create another way and test it again. So this is where they're going to earn their points in 2B. If they keep a journal and then write down all these notes during their development of their process and their project, they're going to be good. So some of the things as a reader that I notice where kids have problems or they don't get the point. All right, number one, I stressed it a lot. I talked about how they have done the development process. Don't talk about the coding here. All right, it's not just about the code. They want to hear how they came up with the idea and all the things that I just gave you as a demonstration. What hurdles they faced, then what did they do to test it out? All those things were important. I recommend your students use keywords: reflect, revise, tested, refined. I got feedback. Okay, it's important. First, I did this. Then I did this. Then I tested it. Then I talked to little Joey next to me, and then little Joey said that I should do this. And I was like, wow, that's a really good idea. I should do that. That's what they want to see in 2B. Okay, there is no credit given if they just talk about how they came up with the initial idea. All right. Yeah, me and my friends were talking about this idea, and kids needed glasses, and we decided we're going to make an app to get kids glasses. Done. Okay. If that's where they've done it, they get 0 points. All right. So that's the first part of 2B. They get 1 point if they do that. Now, they get one more point if they do this, and that is talk about 2 difficulties or opportunities that they faced during the developmental process. So, what's a difficulty? It's a problem they encountered. So, for example, they might have come up with one way of doing it, and then when they tested it out, it wasn't going to work. So then that's a difficulty, and then they would have to talk about what they did to overcome that difficulty, all right? In my program, I was doing this, and then all of a sudden it wouldn't work. So after doing a debugging procedure, we decided if we used a loop in the code, we would be able to then have the program work successfully. Awesome. That is a difficulty that they overcame. Or they can talk about an opportunity. So a girl was playing my game, and then as she was playing, she said, hey, you know, it would be really cool that if you added a fireball, and then when the fireball hit the plant grew in size and became even deadlier. And you're like, wow, you know what? I'm going to put that into my game. That's an example of them taking advantage of an opportunity. Now, the important part of this section, they have to talk about 2. It can be 2 difficulties they had, 2 opportunities, or 1 of each. But they need to address 2. And if they do talk about how another student helped them out with the testing, they just have to make sure to give credit. Tell them don't be afraid to give credit. It doesn't mean that they're going to think they're cheating. Obviously, if you're going to need help debugging your program, say that little Joey helped me debug my program. Now, we just got 3 rows. We've gone through 3 points. Now we get to the algorithm. Now, I usually find out when by training other teachers, when I do workshops and things like this, and I talk to other teachers through our teacher support here at the UTeach Institute, I always find out that the algorithm is what the teachers stress the most about. And it's usually because they want to make sure they're teaching their students what algorithm to select, like what is the right one to choose. You write this whole giant program, you got all this code, you know, how do they decide which one to pick? All right. And we're going to talk about that because that's what the students have to do for response 2C. In 2C, it's all about applying the algorithms. And part row 4 is actually putting in the segment of the code that is the algorithm they want to talk about for 2C. If you look at row 5, that's where they're going to talk about the selected algorithm. And then in row 6, they have to talk about the logic and math in it. So you can look that over, but what I want to get into is how they're going to basically, how you are going to teach them what algorithms to select and which algorithms are correct and what an abstraction is when we move on to rows 7 and 8. So here's the first thing you need to know. And I'm going to show you examples of this in the following slides. So don't panic. All right. First things first, they have to choose an algorithm that includes math or logical concepts. Now, UTeach, in our curriculum, we use Scratch. And since we use Scratch and processing, most of our students, I would say 98% of them, they usually choose Scratch to do their create task. So the examples I'm going to show you are mostly Scratch, and it's just because that's what our teachers use. But it's okay if you use Python or other programming languages. Just make sure that whatever program they submit, whatever section of their algorithm, it has math or logic into it. Now, the other thing is the algorithm needs to integrate 2 or more other algorithms into it that involve math or logic. So that sounds really confusing, but it's not. And when I show you the examples, I'll be able to explain it better. But basically what it means is you need to have an algorithm that does something, and then another algorithm that does something. And then this third algorithm is going to use the information from these 2 previous algorithms in order to get its result or work. So that's what they need to select. And sometimes they call that the main algorithm or the super algorithm, but just they're looking for an algorithm that integrates 2 other algorithms into it. Sounds confusing. I'm going to show you an example. Don't panic. And then they must use abstractions to manage the complexity of their programs. Okay, so that's going to be also, but that's actually more in 2D. And more importantly, they need to use keywords in this response section like what and how. As a reader, I look for those 2 words, what the selected code segment is supposed to do and how the code works to accomplish that task. So whatever code that they're submitting, they need to explain what it is supposed to do. This is the code that does this specific element in my game. It determines this aspect of it, all right? And then this is how it works. It starts off by calling a variable, and then it's going to do a repeat loop. And then, so it's important to use the terms what and how. And if that's how they think of it, what the selected code segment is supposed to do and how the code works to accomplish that, they'll get the points for this section. A lot of students get that confused. So, teachers, what's an algorithm? All right. Well, we teach our students that an algorithm is like a recipe. It's a list of instructions. It's sequential. Okay. So, for example, right up here, move 10 steps is not an algorithm. It's just one code, one code block. Okay. This is an algorithm. Why? Because it's a sequence code of blocks. All right. But the problem is it doesn't include math or logic. I will draw a square by putting the pen down, moving 10 steps, turning to the right, repeating that a bunch of times. Okay. But since it doesn't include math or logic, that is not an acceptable algorithm. So if all your students have is something that's going to dance on the screen and it's just a lot of move, wait, move, turn, sound, one of those, not going to be an acceptable algorithm. Now, this is an algorithm that uses math or logic. Okay, I'm going to want to draw a square again. Okay, but since I use logic, okay, I use my repeat block right here. Okay, that's iteration. Okay, that is acceptable. I know it seems like it's not very, in detail, but this is an example of an algorithm that uses math and logic. So if you're if you're using Scratch to teach this course, if you're a UTeach teacher or you're any other teacher, or even if you're using Blockly or any block-based language, we're all very similar here. These are logic blocks, okay? Repeat until, if something, then something, or else do something else, right? Right? This would be what you would want your students to be submitting as their algorithm. It has to include blocks that have logic in them, all right? or math. Now, I know in Scratch, green blocks are math blocks, but I would like to say that our and or not, I would consider those more logic blocks. Now, technically, we can sit here and talk about mathematical logic blocks, but we're not going to. Let's just stick with these are going to be logic. And of course, mathematical concept blocks, not only can it be the math blocks, but it can be change X and change Y, right? And that's important to understand as well, because when your students are creating abstractions, if they want to create an abstraction and then use that in an algorithm, and let's say they want to make a jump button or something like that, they would have to change their Y-axis, because when you jump, you go up by a certain number. So just that is an example of a math concept, and it's not one of the green blocks. So don't just think, oh, it has to be green. No, you can use your change in X, Y axes by blocks as well for math concepts. Okay, now, one thing I want to just hit home is they want them to talk about the functionality, okay? Functionality. So when I'm reading that as the reader for College Board, that means I want a description of how each line of the code of the program works, all right? Don't just think because I'm reading this, you know, if I'm a student, I'm sorry, if you're the student and I'm a teacher, you know, you submit this to me and you're like, oh, draw the square. Okay, no, that's the purpose of your project. What's the functionality? Tell me what every single line of the code does. And that's what your students need to do when they're talking about functionality. Okay, so that's what they mean by functionality. Now, program code submission, right over here, just got to remember that when they submit their program, they're going to have to submit the entire program, but they also need to put an oval around their algorithm and a rectangle around their abstraction. So I told you I'd show you an example. Well, here is an example of an acceptable algorithm that they can submit. If you notice, it's taking two other algorithms here, one here and one here, using a logic if-else statement, all right? And it's inside this other algorithm up here, winners and restart. So this is an example of what your students would need to do. They would need to put an oval around the algorithm, and they're gonna have to put a rectangle around the abstraction. And since I told you we like to use block-based, here's a block-based example of an algorithm that works. You see right over here, here's the first algorithm, all right? Then a second algorithm. Inside a repeat until and an if statement, we have another forever here. So this algorithm is incorporating a lot, but more importantly, it is including at least two algorithms in this algorithm. All right, and then we get to the abstraction part. Now, abstraction, don't overthink this, okay? Abstraction is worth 2 points. It's section 2D. And just to let you know, what I just showed you, previous slide, that algorithm, that main algorithm or the algorithm that incorporated the other two, that can also be used for their abstraction. You could submit it for both, all right? So you have your abstraction now. Your abstraction, just a couple things to remember. An abstraction is gonna basically use procedures, lists, broadcasting in Scratch. As long as the broadcast is used in an algorithm, that's all abstractions. When they talk about it, because I'm going to show you an example of an abstraction in one moment. When they talk about it, okay, you know, I want them to state how it manages the complexity of the program. All right. So a student's going to say, I use this abstraction, this jump button that I created, and it allows me to reuse code. It's reducing the amount of code I have to write. It's improving the readability of the code by reducing redundancy. You know, so these are what I would love to see your students, as someone who has to do the readings for a College Board. I'd love to see this be their responses in part 2D. Okay, have them say things like that. All right, that's why you make an abstraction. Okay, an abstraction is to reduce complexity. So in Scratch, all they have to do is make a block. If they do a make a block, like I like to say, if I create a jump button and I say jump button means go up on the y-axis plus 10, wait 0.1 seconds, and then go down maybe -6. Then I jump up, come down. Yeah, I don't want to rewrite that code every time I want to jump in my game. I can create a jump block. Okay. You can also use broadcast messages and clones, and as well as certain types of lists. So this is an example of an abstraction. that is acceptable. You can see here, it's a really good at one actually, and this is provided by College Board. Again, these examples are all provided by College Board. Create a clone, so cloning is in there. Also, broadcast signals is in there, so that's a good abstraction. All right, teachers, very quickly. You do not want to be the teacher who does something that they're not supposed to do while administering an AP exam, and then all of a sudden, College Board knocks on your school's door, and not only are you not allowed to teach AP CSP anymore, your school can't teach any AP classes anymore. So these are some things I just want to clarify for you, because when I do workshops, I get this a lot. Okay, and we're going to put it in our do's and our don'ts. So you are allowed to provide reminders and clarify prompts to the whole class. Hey, let's say the class doesn't understand what they're supposed to put in box 2B. Tell the whole class, go to College Board's website, look at the 10 examples they have there, read the written responses, and look at what the kids are writing for 2B. You're allowed to do that. You won't get in trouble. You are not allowed to provide any assistance to individual students. You're not allowed to do that. You can only provide technical support. Technical support means, is your mouse plugged in? Is your computer turned on? Is the Wi-Fi working? Can't help them at all, okay? You are allowed to support students choosing their own topics. So you can support students choosing their topics. You can't assign it to them. You can't say, hey, little Joey, you're gonna do this. That is not allowed. Even if you think you're helping the students because you're steering them to a topic that they're interested in or you think will be, manageable for them to do, you're not allowed to do it, all right? Encourage students to work together on the debugging of their programs. I like that idea. I think it's good. Do not write, revise, amend, or correct any student work, and do not let students, like I said earlier, work together on the video or any part of the written response. Students cannot collaborate on answering 2A, 2B, 2C, 2D. It is not allowed, okay? Tell students to create new projects, or they are allowed to add functionality to previous projects they did in your class. But now let me explain what that means. If they have a game they want to use that they made in your class, okay? If they have a game that somebody made, and that's cool, but they need to add severe functionality to it. Just changing the main character from a cat to a dog does not count. Now, if they add a whole new level to the game, that's okay. If they add a player 2 that works with player 1 on the screen, and then they have to recode the game for that player 2, that is also acceptable, okay? But they can't just take a project they did before and submit it. That is not allowed, and that is on you as the teacher to try to police that and make sure it doesn't happen. Now, just some logistical things to remember. Before you start the create task, make sure your students can do the following. Make sure you teach them how to screen capture and screen record. Make sure they know how to convert documents to PDFs. It blows my mind how many people just don't even know that in Microsoft Word, you can change the save from docx or doc to PDF. Make sure your students also know how to add transparent rectangles and ovals to the documents that they have to submit. So they need to take all of their code, export it in a PDF document, and make sure that they put a rectangle around the abstraction and ovals around the algorithms. They have to be able to do this independently. You as the teacher better make sure they know how to do this ahead of time. They need to also know how to upload the documents to the AP Digital Portfolio. Usually they learn how to do this during the Explore task, so that's a good practice run and gets them prepared for this. Make sure you designate at least 12 class hours in school to complete this. It's got to be done in class. You can't tell them to go home and do this for 6 hours at home. You can get in a lot of trouble for that. It needs to be 12 hours in class. So just keep that in mind. Now, how you break down that 12 hours, totally up to you. My students like to have 3 hours in a row to work on it for 4 days. It takes a lot of scheduling on my part to get teachers to give up their time, make sure my students make up classwork, but however you want to do it, you can just do it over 12 class periods if you have 1 hour periods, or 14 classes if you have like 50. However you want to do it, make sure you give them all the time in class. You can review the files they submitted to make sure that they are correct and that they're not corrupt. I'm not kidding you. I'm a reader for College Board. Make sure to check that they submitted a PDF of their written response. I can't, these are all true stories. I opened up one student's PDF, which is supposed to be their written response, and it was their parents' taxes, the PDF of their parents' taxes. Another student, hey, sent me the PDF of their Taylor Swift ticket for the concert that they were going to see. I love getting free concert tickets, but I would rather have seen their written response. So you're going to have the opportunity to make sure that what they're submitting is the written response. You are not allowed to read their written response and give feedback on it, but just make sure it's a written response and make sure it's what's supposed to be uploaded. The video is a video, okay? It's not, like I said, something else. And you have to check for plagiarism, okay? If you find anyone that you think is plagiarized, you're like, oh my God, my student copied this from College Board's website, or this is from another student in my second period class, you need to flag it. If you don't flag it, you can get in trouble. You can get in trouble for not flagging it. Student will get in trouble, but so will you. Okay, so just to let you know, the UTeach curriculum, if you're a UTeach teacher, we have this amazing Create Task module. We provide, and by the way, if you're not a UTeach teacher, go to UTeachCS.org, look into our curriculum. If you could hang out for one more slide, I'm going to show you how you can make $1,000 and get access to our curriculum for free for 2 years. But make sure if you do use our curriculum, you could just follow our Create Task module. Please notice we have an introduction, planning, programming, written response, and submission. Notice we do everything. Students start off by learning about what I just taught you. They mock grade examples. They go through a research phase, a long time of programming and making their journals up. Then they do worksheets that help them on the written response. And then we even have worksheets and lesson plans for you as the teacher to do the submission process. So all of this is included in the UTeach curriculum. If you're a UTeach teacher already, use our Create Task module. And if you are not, go to UTeachCS.org and look into us. Now, like I just promised you, how would you like to make $1,000? So if you already teach CS principles, or you're going to be a first-year CS principals, and you agree to use UTeach's curriculum, you would qualify for the following. And I'm just going to briefly touch on this. If you want more information, please go to the bit.ly link on the bottom. But you get our curriculum for free for 2 years. You'll get a free 40-hour PD online ran by myself during the summer to basically introduce you to the course, see our teacher materials, teach you how to use Scratch, teach you how to use Python. And you as a teacher get $1,000 stipend. There are more catches and there are more details, but if it sounds like something you're interested in, free curriculum, free PD, $1,000, please go to that bit.ly and find out more information on it. So just to also let you know, we have a UTeach CSP course, obviously. We also have recently been endorsed, or we're actually in the very, very last phase of endorsement for our CSA course. So if you're a teacher and you've used our CSP course and you're teaching CSA and you like our unit videos and you like our detailed lesson plans and our wonderful pacing guides and how easy it is for students to access our materials, it's an opportunity to continue down using UTeach as your instructional curriculum. So if you have any questions, please put them in the chat box. I can answer them now. If not, you'll be able to access these slides, the entire slide deck. The webinar will be available at UTeachCS.org. We have a tab there for webinars. We also have previous webinars that I've conducted. So if you want to learn more about CSP, go watch more of my webinars. And if you are a UTeach teacher, remember that I am here for support. We're getting down to the end of the year now. I'm here to answer all types of support questions for you about the curriculum, about the tasks, about condensed time frames. So keep that in mind.